and if you follow them, it will make sense. However, I do find me reading them to you first and then going in and working through it kind of gets confusing because you're like, what does that even mean? Because you can't see how it's actually happening. So we're going to kind of know that our instructions are there, but I kind of want to point to an example first to kind of show you how this is going to work. Anytime you get a question like this and we ask you to solve the inequality, because basically that's what the directions are going to be, one of the things I want you to notice immediately, how this is going to be different from what we did with equations, is when you go in and you look at these problems, you should see a less than or greater than sign. So I have a less than, a greater than, and on the back, I have a greater than, and I have a less than. So these are signals that I should be getting an answer in interval notation. Now, on the directions within questions like this on your test, we even go as far as to tell you, make sure you write your answer in interval notation. So that should also be a big like sign that you need to be including all of these steps. So one of the first steps that we have listed is move all of your terms to one side, which for example, 1, we already have. And then step 2, or part of step 1, it says to factor. So I'm gonna look at number 1. I have all of my terms on the left-hand side. Perfect, step 1 is almost done. The next thing I have to do is factor. So again, in order to be able to factor, you are looking at your standard form, ax squared plus bx plus c, and you are trying to see what multiplies a times c and what adds to be b. So in this case, my a times c is -7. My b is -6. So I want something that multiplies to be -7 and adds to be -6. -7 and +1. You do not have to write these two numbers in any particular order. You can write them in whatever order you want. Now, a little note here. This particular problem is an a equals to 1. So because a is equal to 1, the shortcut for factoring is okay. So I can just go in and I can say, okay, I know the numbers are -7 and +1, so I can use x minus 7, x plus 1. That trick only works when a is equal to 1. If a is anything else, -1, +2, -2, -15, whatever, anything other than 1, you have to go the long way, split the middle term, and do your 4-term grouping. Now, I have my 2 factors. So we did step 1 in the directions. So for step 2, it does say to go in, solve to find the critical points, and draw a number line with your critical points on it. So this, again, is pulling from 5.2. So a lot of what we'll do in quadratics in this entire unit relies on each other. Algebra 2 is not one of those subjects where you can say, I did really bad on the Unit 4 test, it's not gonna matter, I'm just gonna do better on the next one. A lot of this is going to carry over. So you have to go back and you have to reteach yourself if there is something you did not learn, generally. And for the most part, we tell you, like, you're gonna have to know this later. Like when I say factoring, you're going to have to know how to factor later. So I'm gonna go in, I'm gonna set each factor equal to 0, x minus 7 equals to 0, x plus 1 equals to 0, and I'm gonna get x equals 7 and x equals -1. Now, this is exactly what you would do if you were just solving by factoring. This would be your stopping point. That's all you need, x equals. Now, because this is an inequality, we're going to take this to finding solutions. So I'm gonna go in and I'm going to draw a number line. Now, normally I tell you your answers, I don't care what order you put them in, they're both correct. On the number line, your numbers have to be in least to greatest order, numerical order. So I know I have -1 on the right. However, it is the smaller number. So I'm gonna go ahead and put -1 on the left, +7 on the right. I don't care how you scale it as long as the numbers are in order. Typically, every single number line that I draw looks the same. Even if the numbers are different, the distance between the numbers are different, doesn't matter, they are the same. Now, just to kind of go in and talk about the points. So there are two options, and I know it's all kind of explained up here in terms of like every situation you can encounter, but I kind of like taking it out of those words just so you can kind of see a little bit shorthand of what this actually means. If you have less than or greater than, you're going to have an open circle. If you have less than or equal to or greater than or equal to, you're going to have a closed circle. This is exactly the same idea as when we were writing domain and range. Basically, these would be parentheses if it was an open circle, brackets if it's a closed circle. And all of that decision relies on the original question. So my original question doesn't have the equal to sign. So when I come in to draw my circles at -1 and +7, they're going to be open. The only reason they would be closed is if I had the equal to sign there, which I don't. Okay, that's kind of the new bit. Any questions so far on why it's open or why it's closed? Sweet. Okay, now the way that we kind of approach this next part is we do a tester point. And so you kind of want to see where your 0 is for the most part. So if I were to find 0 on this number line, would it be on the left? Would it be on the right? Would it be in the middle? In the middle. So I'm just going to draw a little line for 0. And then all you want to do is you want to be in the places where your inequality is true. So I'm going to take my inequality, the original problem. So I'm going to go into the original, and I'm going to plug in 0 squared minus 6 times 0 minus 7 less than 0. So when I go in and I simplify this, all I did was take x equals 0, plugged it into the original problem. 0 squared cancels out. 6 times 0 cancels out. And I get -7 less than 0. Is that true or is that false? True. You always want to be where your equation is true. So since my 0 is in between these two numbers, my shaded area is in between these numbers. You are either in between them or you are outside. Those are your only two options for problems like these, inside or outside. There's no like this left one, but not the right one. It's inside or it's outside. So, and just to make a little note here, you want to shade where it is true. So, in this case, it's true. I'm shading inside. Now, the only thing you have to do is write this in interval notation. So interval notation depends on what's my starting value, what's my ending value, am I including it, am I not? So when I go in, my starting value is -1, and because it's an open circle, it's going to have a parentheses. So this is exactly kind of like how we wrote domain and range. -1 all the way up to +7, and that is also going to have a parentheses. In questions like this, you will not have parentheses and brackets together. They're either both parentheses or they are both brackets. The only time you'll have a parentheses and bracket together is if you're going to an infinity, which we'll see in just a second. So this is going to be my final answer. We're going from -1 to +7. Any questions so far? Okay, let's see a couple more. I'm going to show you all of the possibilities for what you could get as an answer in any of these problems today, in these 4 ones that we have. So I'm going to go to number 2. I already have all of my terms on one side, so I'm going to go straight into factoring. Now, this is one of those special case factorings that we talked about in Unit 4. If you remember, we talked about a squared minus b squared is equal to a plus b, a minus b. Both of these terms are perfect squares. So I could go in and I could say factored form is x plus 1, x minus 1 greater than or equal to 0. And I have my factored form. Anytime you have a binomial, two terms, always check first if there's a GCF, and then check if it's a special case factoring. Usually those are your only two options. If you forget this rule and you don't remember it and you can't think of it, you can also still use, if I want something that multiplies to -1 and adds to +0, I'm going to use +1 and -1. So our regular factoring method works even on a problem that is a difference of squares. So it's still okay if you don't remember that one. And the reason why this all is able to use a shortcut is because this is an a = 1, just to point that out. I'm going to go in, I'm going to take both numbers, or both factors, and set them equal to 0. So I'm going to get x equals -1 and x equals +1 on the test itself, because I know some of us will get to a point where we can kind of see these and we know where the shading is going to be. One of the test directions says to include your number line, so you have to draw out your number line. You have to label it, you have to shade on it. So I'm going to go ahead and put my -1 and my +1. And because in the original problem, we have the equal to sign, these are going to have filled in circles. And that's going to be dependent on the question itself. The only thing that determines that is the question that we give you. Now, would 0 be on the left, the right, or the middle? The middle. So I'm just going to put 0 in the middle. And that is mostly so that we know where we're kind of checking our test point. So I'm going to go to the original problem, and I'm going to plug in 0 squared minus 1 and see if it's greater than 0. Anything you multiply with 0, zeroes out. So this 0 squared, gone. So I end up with -1 greater than or equal to 0. Is that true or is that false? False. Now, remember, our little note said we want to shade where it is true. So since it's false on the inside, that means it has to be true on the outside. It's either inside or outside. One of them is true, one of them is false. So if you happen to test a point and it ends up being false, you need to go to the opposite place of where you are. So I'm inside, I'm shading outside. You will see that I mostly check the point 0. You don't have to check 0. You could check 1, you could check 2, you could check 15 if you really wanted to. And you just have to know where they fall on your number line and see if it's true or false. I check 0 because it works out pretty nicely because most things cancel out with 0. But 0 is not the point that you have to use. You can use anything. You can use +1, -1, you could use 100. But you have to have a point to test to see where is it true, where is it false. Now, when I go in and I write my interval notation, because these shadings are going all the way out to -infinity and +infinity, when I write my final answer, I'm going from -infinity with a parentheses, because infinities always have a parentheses, all the way up to -1 with a bracket, union, +1 to, oops, I did a negative, to +infinity. So if you, in Unit 1, thought, wow, I'm never going to learn interval notation, there's no reason for me to know it now that we've taken the test, surprise, it's back. You do have to know interval notation for quadratic inequalities, and you will have to know it for domain and range in the future. So if you are still struggling with this, again, you need to get to tutoring, you need to get extra help on it, or you need to take the time to learn it again. So, -infinity, -1, 1 to +infinity. Do I have any questions on my interval notation? Sweet, let's go to the back. Okay, now for number 3, I don't have everything on one side, so I'm gonna go ahead and I'm gonna subtract 7x from both sides of the equation, and that's gonna give me 2x squared minus 7x minus 4 greater than 0. Now, when I go to factor this, I'm going to get something that multiplies to be negative 8 and adds to be negative 7. So the two numbers that work for that are negative 8 and positive 1. Yes, ma'am?
I was just going to grab a copy of the notes.
They should be over here, I think. They should be. So negative 8 and negative 7. This one, I cannot go directly and say x plus 1x minus 8. The reason being, a is not equal to 1. If a is not equal to 1, you have to go the long way. So I'm going to go in and I'm going to write this as 2x squared plus 1x minus 8x minus 4. And then I'm going to go do my 4-term grouping. So this only has to happen if I have 4 terms.
Is there a review?
It's probably on that side. And if there's no review copies, I'm probably out.
Okay, no worries. Thank you.
There should be a PDF on mine.
Okay, perfect. Thank you.
And so I'm going to group the first 2. I'm going to group the last 2. With the first grouping, you always want to check for a GCF. My GCF in this case is x. So I'm going to end up with 2x plus 1. What is my GCF for my second grouping? Negative 4. Now remember, if you only pulled out the positive 4, your parentheses wouldn't match, and that would mean you could not have your factored form. The whole goal of 4-term grouping is that your parentheses look exactly the same. So I have a 2x plus 1 and a 2x plus 1. So that means my first factor is 2x plus 1. And my second factor is going to come from the GCFs that I pulled out. And I pulled out an x and I pulled out a negative 4. So I'm going to have x minus 4 greater than 0. And then I